Hello everyone, welcome to TechnoX. We have our guest Sarah Tamilarasan, CEO of SotaOG, and she will be telling us about how machine learning algorithms can be used into the energy sector. So welcome Sarah, and now let's begin. So what exactly will you define machine learning into the business approach? What is the machine learning and how is it implemented?
Yeah, absolutely. So there's so many tech stacks within machine learning. So for one example, the easiest and simplest one is our clients and several others, like you sell product from tanks. These are big tanks, they're 1,000 barrels, whether it's diesel, chemical, or whatever it is. You have tank level sensors on it. And then you have a truck that comes and pulls off your product. The product in the tanks are your cash on hand. And the product that leaves on the truck is your estimated revenue, right? And it's a paper ticket, believe it or not. Even in the milk industries and everywhere else, these trucks will leave a paper ticket. So what we do is we actually use the sensor data and we'll estimate your revenue on an everyday basis first. And then when the workers or the field people will just take pictures of the ticket, typically before machine learning, they have to look at the ticket, they have to figure out which tank to associate it with or which site, and they typically make so many mistakes on an everyday basis. Just imagine thousands of barrels of milk or water or oil that's being transported and sold on an everyday basis, and you're manually trying to reconcile these tickets. Lots of issues happen, and they only get paid once a month.
Okay.
So we autonomously reconcile that using AI and machine learning and through OCR. And at the end of the month, when our clients get the payment, they have to list out the ticket numbers. We already have the ticket numbers stored. So we will autonomously check for the ticket numbers. So a lot of our clients actually get money back because a lot of the tickets that they would have on hand doesn't get paid.
Okay.
So we'll instantly generate that list and they'll send it over to the purchaser and say, please pay us, we have these tickets.
Great. So it's basically a mixture of automation and the machine learning into it.
The automation's already there. You're analyzing it. So sensors are already there.
So basically I saw the platform SotaOG and I saw the premium prices and everything about like what's the basically pricing sector of it. So if you are charging someone for some particular service or something like that, so how do you define basically that what particular segment will that be, and how the machine learning you are implying and scaling it to provide the different pricing strategies and everything?
Say that question again. So we're very specific to energy and heavy industrials. So you have to be making something and you have to be selling something every day.
Okay.
And you should have, typically these industries have been around for 100 years since the Industrial Revolution. And typically the solution that exists today is automation and a SCADA system where people have to manually look at it.
Exactly.
So if you make a mistake on reconciling that ticket to a tank level drop, we're estimating revenue based on that. And we're also triggering sensors that are not working. It's not basic automation, right? So there's a basic automation that's been used, but it's very reactive.
Okay.
So we look at patterns and we can tell you when the sensor is going to fail. And then we'll say, if this sensor fails, we cannot estimate your revenue. You should go fix it before it fails. So these are all, so for example, we run, and then we predict what your cash flow will be tomorrow based on the cash flow assets. So there's several moving parts. Like for one small client, we run like 1 million computations a month.
Yes.
On different, so it really depends on the use case, but you're essentially, it's not maintenance because maintenance costs money, but if you can do it from a cash flow perspective, it's different.
Okay, so why energy sector only? Why you choose the energy sector only to get into this particular thing?
Because of my background. I come from 15 years of experience in that space. And I
Okay,
saw this
so
problem firsthand. I saw it
mhm.
internationally
Okay, so
as well.
how do you think that this particular industries who are from 100 years or 150 years will adapt to the machine learning algorithms? Like what exactly are you solving and getting them the profit thing to so that they adapted to this new technology?
You show them the value
Okay.
and you educate them and you say, hey, we know that this problem exists. And we always approach it and say, this problem exists for like uh, this other person out in the middle of the desert, right? Does it exist for you?
Yeah.
And you run into two kinds of customers. Some don't want to change,
Mhm.
and that's okay. But a lot of the majority of the time, they do because they don't want to. Using, like, for example, we just are replacing like 50 plus reports for a
Hmm.
client, right? Because we're autonomously analyzing it. That report never needs to be done by hand anymore.
Okay.
So when you look at the human cost for that
Hmm.
report and AI, it's so pennies on the dollar.
Definitely.
It's like
Yes.
1 cent to a dollar, right? Like that's how magnitude, it's different.
Exactly.
So you
So
show that, yeah. And
yeah. Go on. What you were saying.
no, I think you show and you communicate that in a very simple form. I think that adaptation becomes easier.
Okay. So basically, what's the general consideration is that AI and machine learning will, reduce the jobs, reduce the need of humans into a particular segment and that particular thing. So if you are like shifting towards the machine learning, and if you are making it more and more autonomous, like reports thing that you see, in the fundamental way or in the traditional way, they were either not focusing on that thing, or if they were focusing, it was taking a lot of time to generate reports and then getting a narrative on that and then taking action on that. It was taking a lot of time, which are being reduced due to the machine learning algorithms and generating the reports very fast and getting actions fast. And that also can be automated. Even actions can be automated and integrated. So the use of people that were doing those things. So how do you think that this will go for another 5 years? Like the trucks that are moving driverless and the things that are that like there's no actual need of the things, the humans into this particular thing. How do you think it will be projected for 5 years?
I don't think the human element ever really leaves.
Hmm.
I know people think that the human part gets canceled, or, you know, uh, I do think you'll have truck drivers for the next 5 years. But the goal for businesses is to enhance the productivity of the existing people
Yes.
because um, you only have a budget for payroll for X amount of people. And no, there
Hmm.
isn't a business COO that I have met that says, I want I want a million computations a month, right?
Yes.
Uh, and I have excess budget to hire thousands of people to do that, right? They really just want their existing people to do more things. This
Hmm.
frees up. And so actually you'll be surprised. Technicians, like they have 30 years of experience, they're smarter than just writing a report. If you can unlock and use the human capacity to think, which artificial intelligence can't do very well, and make better decisions. Like if a technician is fixing something versus writing a report, fixing something is more valuable using
Yes.
their experience, not writing a number, right?
Yeah.
So it's you don't really lose. None of our clients are thinking of reducing their workforce. They're thinking of not hiring anymore. They're thinking of
Okay.
being more efficient and productive. Productive.
Exactly. So retaining whatever they are and making them more productive by using this modern technologies and all.
Yeah, because if we don't, someone else will. The
Hmm.
technology is here now, and the
Yes.
technology is inexpensive now. 5 years ago, it was very expensive. It's not so expensive anymore.
So if we put this energy sector apart, what do you think the machine learning can do in the terms of like changing the future of the world, and like what will it have? What will be machine learning projecting to this thing? Learning in each and every business, this particular particular thing a lot, data or recommendations using many particular business sectors are used. Other than energy sector, what's your point and your take on use of AI and machine learning?
I think it's already being used, and like you gave all these examples, right? We're already using it every day. You're using it every day. Like you said,
Yes.
Netflix and everything else. It's made your life very productive, right?
Yes.
And now you even see banks. It hasn't quite hit the industrial world because that intelligence to take it from start to finish was lacking. So it's hard to plug in an AI model in an old factory, right?
Yeah.
How
And
do
that
you
was something
know?
innovative. That was something
Yes, so how do
innovative.
you,
Yes.
exactly. So you need to know the know-how, and you need to bring your cost for that service down. So I see huge potential. And the issue that I think the IBM and the big companies failed was they took so much cash up front and they didn't deliver. And then it was only for the big companies, and they had all the money anyways. So even if they didn't deliver, it's not a big deal, right? The smaller companies, you have to deliver. And I think it's a lot of potential in a good way. Like, who doesn't want a small farmer to grow more crops?
Exactly.
Who doesn't want a small, or a small factory owner to make more and be more efficient? We all do. That helps our society. So I think it's got a huge potential, and it just needs to be distributed very well. And it will make a fundamental impact on where we live and how we live in a good way. I don't necessarily think it will encourage people to be more productive and think more. Like we see field people that had 30 years of experience, like I said, if they're out there fixing machines, way more useful for the factory worker than if he's writing something down.
Okay. Like if you see the implementation of machine learning into a particular perspective, if I particular put like in the terms of indicators, okay, each and every particular business have some indicators, have some key indicators which due to which we can project their growth or project the revenue or their cash flow, their profit margin and everything. So based on those things, you have the calculations, you have the reports. So what are the data points that you touch and optimize to get a particular productive result? How do you decide that?
So we touch sensor data. We touch machine data, right? That is changing all the time, every day, based on what you're doing. Like, let's say you're making 10 bottles a day versus 5 bottles a day. That sensor data is changing all the time. So you can estimate and make projections based on that. You just have to combine it with that static data, like I said, with how big that machine is. So if we take a pump, for example, and then you have to look at the interdependency of that machine with the next machine.
Okay.
Because you got to analyze it. So you analyze it component-wise with the 3 parts and look at variable operating expenses. So like, for example, on a pump, power is a variable cost, but rental is a fixed cost.
Exactly.
So, so you got to combine all of this data intelligently, build those models component-wise, and then optimize from an overall perspective.
Okay. And if you see the results, like generating cash flow, so how that can be optimized over a year, like over a period of year. So what basically is your approach to increase that thing quarterly or like half yearly or yearly, basically to get get that green signal of
percentages? For us. We're trying to increase it every day. But they only get paid monthly. That's the problem. So like on a monthly basis, we do try to drive those results on optimizing components of the machine. So it's interesting in operations. We meet a lot of engineers that only know one thing. Like if they know a pump, they don't know how a pipeline works. And it's like, okay. So they're learning too. So we are increasing that intelligence level of their existing technical folks as well. They kind of know what a pipeline and how that works, but they really know only a pump. But
Yeah.
the optimization is a combination of both, because the water is pumped by the pump and then it goes into a pipeline and it's metered, right? So
Hmm.
the meter is the one that tells you how much cash you made.
Exactly.
And if the pipeline has a leak, then everything gets lost, right? Like, who cares about the maintenance of a pump at that time?
Hmm.
So
Yeah.
how do you, so you kind of bring all those data points together and analyze it.
Okay. There's a thing like if the thing that you mentioned about like using the machine learning or modern technologies into the old industries, है ना? So how do you think what is the market share right now? How much industries, the old industries, have incorporated this thing, this machine learning algorithms are and optimizing? So what is the scope of growth of this?
I think it's huge because it's very little. So you'll hear about monitoring solutions in the market, SCADA solutions. That's everywhere.
Mm-hmm.
And I've been in the industry for 15 years. I got trained on SCADA, right? But that's a control room center. You have to sit there
Yeah.
and look at it, right?
Uh-huh.
That is a very crowded market today.
Okay.
I do think AI and machine learning will come in the next 5 years.
Mm-hmm.
But the cost of affording it is so expensive that the small companies can't. I don't know how, but we are very focused on driving that value for the smaller industries.
Mm-hmm.
We would even, like, for some companies, we'll say, hey, you don't have to pay us until we drive value for you. We don't drive
Exactly.
value for you. We both should shut it down because I don't want to lose money. I don't lose my time.
Yeah.
And you get, and not a lot of companies are doing that, right, for the smaller guys, because
Mm-hmm.
you got to educate them. There's this big education portion that comes into play,
Hmm.
and then you have to make them believe after the first month. They're like, okay, yeah, I kind of like this. Like, most COOs today do not know how much cash they made today, instantly.
Okay. Okay. And that's very much the beauty of this thing, that you get generated reports daily perspective, and you can channelize it. Yeah.
Yeah,
So
they used to check monthly. Now they want to check daily. So
yeah.
we're helping, we're growing.
Yeah. And that's a very good metric actually, because in our internet businesses also, when we check like how much people are coming onto the websites, and we generally match like how much today came, how much yesterday came, okay, we are growing or not, something. So yeah, metric works, and that revenue metric is very well thing for this thing into the industry's perspective, if you see.
And a metric for operations business changes every day.
Hmm.
Like, oil price could go down, for example, or the bottle price could go down by 5% tomorrow, because it's a commodity-based business. It's
Exactly.
traded on the market with shares, right? So it goes down. You can't control that. You can't control commodity pricing. The only thing you can control is the productivity of your operations.
Yeah,
And your
that's how you
cost.
generate profit. Yes.
Yes. So if your target is to make like 500,000 a day, and prices go down tomorrow by 10%, you got to make more product to hit that 500,000.
Yeah. So definitely. So the optimization of this, like, do you parallelly run this thing also, like that you said, the commodity pricing and the stock market thing of that, and the your approach of maintaining the like metrics, generating revenue over that. So how do you match and control both of them parallelly?
I don't control it.
Okay.
What do you mean? I analyze it together and show it to them.
Okay. So basically,
So
you also have a projection of the commodity pricing, like what can happen in a month and how you can
no, I don't
optimize it.
predict commodity pricing. I tell
Okay.
them on that day how much they made.
Okay.
And
No. I'm just saying about a thing like you said that suppose tomorrow 5% it drops. So what will be there is they can't just do something day after tomorrow, no? Just to maintain that or maintain
no,
that
they
loss or
can't.
something
They
like
have to
that.
do it that day. So we'll
Yeah.
tell them where the potential is. You
Yes.
always have potential in your existing assets.
Mm-hmm.
And we're always running those calculations for them every day on what the potential is.
Okay.
So one particular client gets different demand on his product. on their product. They're all guys. I'm not a space. But anyway, on their product. So like today they might even say, they'll say like, I need 100 bottles. Tomorrow I only need 9. So we give them optimization on how do you utilize, like for your lowest power cost or your lowest cost of unit to make those 9 bottles. So we're running those optimizations every day.
Yeah.
And those recommendations come out every day. So.
Okay. And has been there any particular incident where like it haven't worked or something like that? So what do you do in that particular situation? Like maybe you build a model, maybe you predicted correctly, you put a team around that and everything you built, and it haven't worked. So what was your reaction on that? Like how you made sure like, okay, it should work again? Like, is it like 30 days every day it's good, or maybe 1 or 2 days sometimes, yeah, maybe it won't work? So how can we make that particular thing?
Very good question. So a lot of times they're handwriting data, right? So it doesn't work. How you beat that is by using an engineering model. So you can always use a physics-based model.
Okay.
And you would accelerate that with an AI and machine-based model, if that makes sense. So yes, a lot of times our AI machine models will say, cannot give results, completely broken, we are like 1000% outside, right? So then you just go back to basic engineering models. Those always work.
Those always, yeah.
I mean, they have a really high probability of working. They have mostly worked for us so far. So yes. I should say that.
Yeah, definitely. Because on a daily basis, if we say like making decisions daily based on some particular reports and everything, it's quite dynamic. And based on that dynamic, decision making should be very much effective. Other than that, it's a sudden decision that you are going to take to maintain that particular profits and to maintain that particular cash flow generation. So,
so if you do physics-based models on sensor data every day, it's better than you can make that decision now.
Yes.
You don't have to wait till tomorrow.
Exactly. That's what. So it's basically solving that dynamic problems and giving a more holistic approach to solve that particular thing. Okay. So Sarah, one thing. Suppose if anyone like you are into the industry from 15 to 20 years, I think more than that. So how would you see? So suppose someone is like learning the data science and machine learning right now. So what do you think his approach should be? What should be here his career roadmap? And what he can see? Suppose maybe he just entered engineering, or like he's just passing out engineering and he's learning data science, machine learning algorithms. So what is the industry stake? What can he see as an opportunity in the industries for the machine learning?
I think the opportunity is great, right? But in older industry sector, they don't understand it. So let's say, I mean, my background is electrical and computer science engineering, right? Back 15 years ago, there was no data science, none of that, right? I got trained on engineering principles. Right? So I got hired as an engineer. I mean, I did do programming as a computer science, but there was no expectations for me to do data science. But early on in my career, whatever position I got hired for, I decided I want to figure out how to drive value for the company. So you want to understand the business of the company, and then you want to understand how can you make an impact on that. So if you're doing a data science project, go an extra mile and figure out what else you can do. How much further can you take this, or what is it being used for? Like, just don't do calculations on pressures and pipelines and frequency, and call it a day. Try to understand who are you helping? Like, are you helping the engineering team? Are you helping this? Like, so that understand the context of what you're doing.
Okay. Sarah, can you tell us about your journey, like how you started, and like right now you are into the CEO of energy operations and into the energy sector. So what was your journey towards it?
Yeah. So I started in oil and gas. I got graduated and I got hired. I got a job. And early on, I realized that I got into big projects. I worked pretty hard. And I realized that in the big company, I kind of peaked. Like, I went to international projects, I went to Africa, Europe, etc. And I decided I'm going to go to a small company that, and then I'm going to learn everything and figure out how this company, like, how can my skill set make an impact on the business? So I had to go to a small firm. So if you want to look at the difference, right? So the company I was at, we made 450,000 barrels a day. The company I went to made 10,000 barrels a day. So I learned very fast what the economics were, etc. And but I always knew real-time data, sensor data, and I knew that it could be used so much more. At the small company, they were doing a lot of manual stuff, and I helped them build out the architecture for sensors, automation, PLCs, and it wasn't a 2 times ROI. It was like a 70 times ROI. So over the next 5 years. So that's, the rest is history. And then we thought, then that's when I had this idea. And people didn't think it would work, but it does. So
great. So tell us about SotaOG. Like, have you started it like as a co-founder, or you joined them at a later stage?
No, it was me and my co-founder. We started together. He is amazing. He is the vice president of Marathon Oil. So he had a lot of experience running several businesses across the world too. So he's got a rich history before Marathon Oil. Now my career started at Marathon Oil. I think we've been successful because we started it together. And from the C-suite, he knew that cash flow analysis was always done by hand. And the smaller you go, they still do it by hand. And then they even try to predict commodity prices, and they always get it wrong. So
exactly. And so machine learning's outcome, like how can you in the stock market thing and in prediction models, like various things they are predicting using the machine learning, whether the market will go up or how it will be projected into the 5 years or something like that. So what you do into the energy sector or maybe commodity sector and everything, if you are using this into the financial sector and making the same machine learning models, how do you think that it will be effective? And now the crypto is also there, cryptocurrencies are also there. So do you think that it's so much volatile, so whether there will be some data points to catch on and build a model or not?
it depends on how much historical data you have, because that enhances your predictability. But I think the biggest value of machine models is you can predict the future with reasonable accuracy. And if you can predict tomorrow or day after tomorrow and make decisions based on that, you're in a much better position.
Definitely. Yes. And that will be the thing. Sarah, it was a very nice meeting with you, and we had a great talk about machine learning. One line mantra that you can give to the audience, to the people that will be watching this later on, that what they should do to get into the machine learning thing. What one-liner advice can you?
Pick something you really enjoy doing, whether it's mechanical engineering, computer science. Pick an area that you really enjoy, and then you can always layer in machine learning after. So.
Okay, so machine learning is at a later stage. First, fundamentals and basics should be very much strong.
The basic should be you should do what you really enjoy as an engineer. And AI can always be layered in. So, I mean, if you're a computer science guy and you love AI and machine learning, pick an area that you really, really enjoy. So you're going to be working for 40 years. That's what I tell people. Like, pick something you enjoy.
Great. I think that will be this, and we will be wrapping this interview, and it will be posted on YouTube very well, and we can share it all. And
all right.
Yeah. Okay. Thank you, Sarah.
Thanks. All right. Thanks. Bye.